Now you might be initially thinking, how on earth do we fit a VR headset to a guide dog? That's not our problem here. That's not quite the angle of the project. And on that point, I will let Leigh explain that any further.
So, good morning, everyone. Today I'd like to discuss an ambitious project that we've been working on, remote guide dog training utilising VR. I was supported on this project by Ian Murray, CEO of Ashkaksar, and Wesley Lamont. This project was also made possible by Curtin, the HIVE, and our industry partner, Guide Dogs WA. This project is aimed at enabling guide dog trainers to train guide dogs and the vision impaired from remote locations by placing a camera on a guide dog's back in location A and a headset on the trainer in location B. So why do this? Why now? Is it safe? And do we have the technology? I would give a simple yes to all these questions, but it wouldn't make sense. I think it would be better served with an understanding of the background of the project anyway. So the usual training process has two stages. In the first, guide dogs are trained and assessed in their ability to do things such as follow commands and stop at traffic lights. In this stage, vision impaired people are also assessed to see if they have the requisite skills necessary to be assisted by a guide dog. In the second stage, the guide dog and the vision impaired person are trained together, first to familiarise themselves with each other, and then eventually on a specific route to be used by the vision impaired person. During this process, they are followed by a trainer who monitors how they work together, assists the vision impaired person, and ultimately decides whether training has been sufficient. This process has been a large success, and is part of why Guide Dogs Australia has been declared the most trustworthy charity 7 times since 2013. However, when training guide dogs in remote locations, the current system is less than ideal. Sorry, I think I said 2017 before, 2013. Training is heavily reliant on the skills of the trainers who must travel to remote locations for training. This causes a strain on resources available to organisations for the vision impaired, most notably human capital, with trade-offs between assisting those in regional areas and those in the city, delays in assistance, or reducing funding available for additional efforts to help the vision impaired. So this is our solution. The trainer remains in the city, the dog and the owner remain in remote and rural areas. The trainer and the trainee communicate over the phone, and video is relayed from the dog's harness to the trainer, along with information such as the dog's heart rate and the speed that they are walking, all viewed through a virtual reality headset. The system will also allow us to provide some health data for long-term use and specialised navigation and direction systems. This has all been made possible by advancements in live streaming, virtual reality, and broadband telecommunication technologies, which have made remote training opportunities viable in many fields as well. As we prepare for our first prototype, we have 10 people working on the project, with some focusing on the harness, some on capturing data, some on transmitting data, and so on. My role has been to design the user interface, which is what the trainer will see and what they'll interact with. So going into the design, there are a few principles that we wanted to stick to. We wanted to preserve screen space as much as possible, to only display what was needed when it was needed. If we did want to display information, we wanted it to be easily processed. We wanted to reduce cognitive load so the trainer could retrieve information at a glance and remain focused on the video stream, what is happening out there during the walk. We wanted all functionality to remain inside the headset. We didn't want the headset to come off. We didn't want the trainer to need to use their phone to check the weather, see where they are, to figure out which way to go. And of course, we wanted the system to be easy to use. We wanted intuitive controls, for things to behave as expected, without thinking, without pause. So here's our design. In the background, we have a 360-degree live stream video. The video is stabilized at the source by the camera. If the dog leans left or right, our eyes remain level with the horizon. If we look at something and the dog turns left, the video doesn't rotate, and so our eyes remain fixed at the same spot. It's as if the camera only ever shifts position, which prevents motion sickness and allows us to use the technology much, much easier. So at the top of this, we have a summary bar, where we include information that is always important to know. Along the top, from left to right, we have a description of the dog's speed, an icon depicting health, network information, and a picture summarising the weather. The health and network information are colour-coded across a range of colours from red to green. Additional information, such as heart rate and latency, are displayed. Below this information, we have the direction system, which ties in with our map system. During the walk, the trainer can use the system to easily relay instructions to the vision impaired person. 2 lines of text are provided to the trainer as they travel from point A to point B. The top line is the instruction that gets them from where they are to the next place that they should be, and the bottom line is the instruction to be provided once they reach the next destination. The text changes size as we travel, so when we're at point A, it is about 80/20, when we're at point B, it is 20/80. This helps keep the information more easily visible while still allowing access to additional information as needed. To the right of the text, we see the distance between point A and point B, and an arrow indicating the direction relative to where the trainer is looking. In this case, the trainer might say something like, walk north for 250 metres, but that's pretty difficult to understand, so you might need to provide constant updates. And that way, as you get closer, you say, we're about 15 metres off, and then we're going to turn right. And this is actually very difficult to do with just a map or through looking through a camera to estimate this sort of stuff. Along with the direction system, the basic idea of the map system is to replace the maps application on the trainer's phone. It can zoom in or out, pan around, rotate, and includes a marker that tracks the direction of the trainer's eyes. In addition to this, the trainer can create, move, or remove waypoints to alter the journey taken with just a single button. If a marker is found within the red circle, it is removed. If there's none in the red circle, but one in the green circle, it is moved to the centre of the current map view. If neither is true, a new waypoint is created, and importantly, new waypoints aren't just added at the end, they are placed in between. And this way we can edit a journey from the one that we had at the beginning, in case you need to make a detour, which is probably the most common operation that we would use, in case there's something that we didn't quite expect on our walks. When a new waypoint is created, moved, or removed, a query is sent to the map provider map box, by the way, which changes the route, which we see in blue, and it also updates the direction system, which we saw on the summary bar. And to prevent this map from obscuring our view, we have it attached to the trainer's wrist. That way we can bring it in and out of view very easily, just like using a phone. Next we have the stats window. It contains 3 categories at the moment: dog health, weather, and network. It has been designed to be modular and easily extendable though, so whenever we want to create new categories, it's very, very simple. The window can be moved around the screen, and its size can be adjusted by the trainer as well. In addition to this, any and all categories that we add can be removed with ease. And this means that the trainer can move it to the position that they want and get rid of the information that they do not need. This will be very helpful for monitoring. And it also allows us to not have it in the way. We found that screen space was the most important thing for us. We don't want to have this obscuring anything and have it stay in one spot. So putting all these pieces together, we see that the design allows itself to be used how the trainer prefers. When the trainer wants to see the map, they simply raise their hand. If they want to monitor information, they select on the stats window, place this window wherever they please. To be notified of any issues, the stats window does not need to be open. We have the most important information in the summary bar, and it can be viewed at a glance. This allows the display to be pretty much free from any information except that which we have decided must always be seen in case of emergency or so on. And that's the project so far. It's still in development. There's a few changes we'd like to make. We want to make the UI more accessible. For example, make sure that trainers with colour blindness can use it. We think that the direction system may be simplified and refined further. We hope to include functionality for public transport as well. There are many small yet important features like checking the time, being able to see which way the dog is facing on the map. But most large decisions, such as control schemes and UI composition, are likely to be driven by testing. At this point, the design exists as a prototype to facilitate discussion and garner feedback. We are expecting the design to potentially change a lot as we add and remove features or change how they're implemented. That was it. Thank you.